This is the Art of Network Engineering podcast. In this podcast, we'll explore tools, technologies, and talented people. We aim to bring you information that will expand your skill sets and toolbox and share the stories of fellow network engineers. Welcome to the Art of Network Engineering. I am AJ Murray, and tonight I am joined by a very special co-host. He is Tim McConaughey from @Cables2Clouds. Tim, good to see you.
Hey, man. It's good to be here. It's been a while.
Yeah, it's been a while since we've had you on the show. Our guest tonight is Shean Leigon. He is no stranger to the show either. He's been on the show a few times. Shean, thanks again for joining us.
Yeah, thanks, guys. Appreciate it, AJ. Tim, thanks for having me.
So Shean is a senior product manager for data center at Juniper Networks, and we're here to talk about AI ops in the data center. And I got to tell you, up until now, we've heard a lot about AI ops in enterprise, particularly around access layer, wireless, and stuff like that. Is AI ops ready for data center?
Yeah, that's a good question, and I love approaching the subject with a healthy amount of skepticism.
I try.
Absolutely, as you should. Quite frankly, that's how we approach it internally as well. It's a little bit cliche, but it's a bit of a journey. So as we say, is it ready for the data center? Yeah, I think it is. We're seeing some things that we're bringing into the data center within Juniper that we think is compelling, but it's also a start, right? This isn't like, hey, we've launched a few things around AI ops, like put a bow on it and let's call it a day, right? For me, I really kind of look at this as like a tool in the toolkit. And so I think like that's the way that I would recommend folks to kind of approach it as well, right? It's not a, it's not a magic wand you're going to wave that makes all your problems go away, no matter what. Here I am as a vendor on a podcast telling you that, right? It's not a magic wand, but look, we think that there's something there, and like I said, it's kind of the start of the journey. Around AI ops in the data center. So yeah, happy to, looking forward to the conversation and for the folks that are familiar with like Mist and Marvis and kind of what we're doing there, I'll be able to kind of relate some stuff to what we've done in the data center. It's similar in a lot of ways.
I've heard some really good stuff about the AI in your the Mist product. So, I mean, if it's the same general idea under the hood, it's probably pretty good, I imagine.
Yeah, it's the same idea, and like the use cases though are a bit different, right? The way I kind of think about it, when you think about like the campus, and it's like especially like on Wi-Fi too, which caveat, like I'm not a wireless guy. I like packets on the wire. You start doing them like RF, and I get lost. I'll leave that up to the real professionals. But what I'll say is that if we think about like on the campus side of the house, right? It's kind of like, okay, I have a bunch of clients. And those clients are trying to connect to applications that exist somewhere, right? But the idea is like you might control those applications. They might reside in your data center. They might not, right? They might be like some SaaS servers, or it just might be general internet traffic going out to other things. And so, there you're really concerned and looking at, like how the client connects back to these different services. And in the data center, I think it's quite a bit different where there, you're saying like, well, I have these services that I'm advertising out, and I have all these other clients that I don't necessarily control connected to my services, right? It's the opposite side of it. And so, a little bit about kind of like what we're doing, in the data center. First of all, it does start with, essentially the Mist/Marvis platform. And so what do I mean by that? We've kind of taken, the platform built on Mist and leveraging like all the Marvis AI stuff and essentially kind of expanded that throughout the product portfolio in Juniper. So you'll hear about things outside of the data center too that we're doing AI ops in other areas within our product portfolio. But when we look at it from the data center perspective, essentially what we've done is kind of take this. I like to think of it like a PaaS layer. Like if you think about that, we've taken kind of like Mist and Marvis, not the controller and the access points, but the AI engine aspect of it. And think about that, like we've just kind of like created this PaaS layer, and we've said, okay, what are the use cases that are worthwhile to go solve in the data center? And, are there things here that we can help, use what's been done in Mist and Marvis to do that? And so, we've found a good handful of them, and we have a bunch more that we're working on too.
All right. Well, let's dive into it a little bit. I mean, just thinking about, what I've seen of Marvis and enterprise and Wi-Fi, some of the common things are misconfigurations, right? Like maybe it's a wrong native VLAN on a trunk or mismatch somewhere else. Is that going to apply to here in the data center? What else? Let's start to build on top of that. Like, let's take what we know and kind of go from there.
Yeah, no, I love it. It does apply and build on top of that, and I think it's worthwhile mentioning too the approach that we've taken around kind of like AI ops in the data center. First and foremost, like it revolves around Apstra, and without spending like a ton of time on it, there's a couple of reasons for that's pretty important. Some folks may be familiar with Apstra. For those that aren't, essentially it's Juniper's data center fabric management solution, but it does more than just manage a bunch of switches together. One of the things that it really focuses on is around like understanding the operational state of the network. So we kind of have this concept of what we call like intended state and actual state of the network, right? And it's a matter of like rectifying those two. And this all gets built and kind of put into this graph database that operates under the hood as the engine of Apstra. And the reason that that's important is because we know things like, what does the network topology look like, right? We know that from the graph database. We know, so we can easily go render that in a UI. Quite frankly, like I don't need AI to tell me what the topology is, right? So there's a bunch of things that we've done there, and so we think about like cabling mismatch. We know from the cabling diagram and basically the cabling map that Apstra builds out, we know exactly what the cabling should be between like all the leafs and spines, right? And we also know what that should be going down to the servers as well. So we can essentially map all that out. So we'll know like, hey, if there's like a cabling mismatch, like Apstra knows that as a single source of truth, but how do we convey that back to users in a meaningful way? I have a couple of videos. I grabbed some screenshots and some things of that I can kind of show that might be helpful. But we look at like that exact use case around like a cabling mismatch, right? If you think about that, one, if it's like, hey, you're just deploying the network and there's a cabling mismatch, like, okay, there's really no operational impact, right? Like you might have to get back on the phone with Smart Hands or whoever was racking everything and say, hey, or maybe you're the one racking it, right? Just all kind of depends, right? And go, hey, something's off here. Let me go figure out, what's happening. And so we do things like fetch LDP information just to go, easily tell you, hey, we think the cable should be in port XE002 and it's actually in XE003, right? Do you want us to either reconfigure it or go move the cable back?
How are you expressing the intent of how it should be cabled, and then Juniper's, Apstra is saying, oh, well, it's actually miscabled, and that's how it's communicating to you? Or because the part I'm missing is you're saying, hey, it should be cabled this way, but are you as an administrator expressing that intent, and then Apstra's kind of keeping you to it, or how does that work?
Yeah, great question. Appreciate that. So what happens is in Apstra, you can, start to kind of build out your network. You define what a rack looks like. There's basically like pre-populated all the network devices that are supported in there, whether it's, Juniper or Cisco or Arista, right? We support a handful of Dell Sonic switches, all sorts of stuff, right? You basically build out a rack. You select what devices that you have, and what will happen is, you could select like, hey, it's a 3-stage Clo fabric, or it's 5-stage, right? Like you can go in there and kind of EVPN VXLAN fabric or an IP fabric, right? You specify kind of like what all that looks like, and what will happen is like Apstra built out the cabling map for you, so you don't have to go and specify each particular physical link. Apstra kind of does it, and there's a bunch of value in that. It's repeatability. The great thing is like, Tim, if you use Apstra to go build one, blueprint in the data center, and then I turn around and I go use Apstra to build the other blueprint in the data center, the cool thing is like all the ports are in the same way, right? It's not like, well, I decided to put, all the leaf spine connections in the middle of the switch and like use port 26 by random, and, you use 00 and 01, for example, right? So it keeps it consistent. And so by being the operator using Apstra, expressing that intent, yes, Apstra turns around and builds it out, stores it all in the graph database, and then that's how it keeps track and it knows. And the cool thing about that, you can do it before any hardware shows up. So you can actually go build all that out. You take the cabling map, you export that, and you go hand it to somebody like maybe Smart Hands or whoever's doing the install if it's not yourself, right? And then they're able to go, kind of implement everything, and you can easily, Apstra alone will kind of alert you to it if there's a cabling issue. Yeah, great question. Hopefully that helped.
Hey, that was great, man. That's exactly what I was looking for.
Yeah, so we kind of take that issue, but let's take it a step further. Let's think about this like as a day 2 issue, right? Like your network's up and running. It's online and active. There's a bunch of applications and services running out of it. And I don't know, maybe something happens and there's some sort of day 2 change that needs to happen, and it could be a number of things, and all of a sudden somebody unplugs a cable. Right. And somebody unplugs a cable and they decide to go plug that back in, and, they misidentified the port, right? They plugged it into port 3 instead of port 2. So in this case, there's a couple of different things that'll happen. One, yes, Apstra, without any AI ops stuff, Apstra's just going to go tell you that the same thing applies, right? That cabling is
right.
But what we're doing with kind of the suite of services that we're essentially throwing AI ops against is now what we'll do is we're making correlation to one, what are the services and applications that's running on that switch, and out of what ports are they running, right? What physical interfaces, right? So we can kind of render that and visualize that and show it to you. But then the other one is actually turning around and saying, okay, now maybe that was a connection between a leaf and a spine, and maybe a BGP session went down. And traditionally, right, all these messages would get generated. We all know from looking at show log messages, you're going to get a bunch of cryptic stuff, and you're going to get some things that actually just make sense, right? And then, maybe you just saw BGP went down and you don't know that it's an interface issue yet, right? How do you kind of separate the signal from the noise, if you will? And so that was the first thing that we've really focused on around some of the AI ops stuff that we're doing is we're essentially running a bunch of correlation against that to say, okay, these types of events are grouped together. We know that these are all related to one another, and go look here, right? Go look at the interface. Don't look at BGP. That's a symptom. That's not actually the cause of the issue here. Go look at the cabling that's been, kind of reconfigured or set up differently, right? Either, correct it by fetching LDP and updating the config, or correct it by having somebody move the cable back, right? You have some options there.
I love that because, we've all troubleshot something, right? And you're, like you said, you're looking at this sea of log messages and you spot something like, oh, BGP. Oh, I know BGP. I can troubleshoot that. And then you just grab onto that for dear life and think maybe I can fix this problem if I troubleshoot BGP. And then, like you said, it's an interface down issue. You're never going to get that session back up if your cable's plugged into the wrong port. So just to be able to use this to, hey, no, that's, like you said, that's a symptom. That's not the problem. Go look here. That's a time saver, right?
Yeah, and that was kind of our target really too, right? It was what we wanted was the simple use cases, not because we're afraid of the complexity, but it was I want the things that are high value and happen often.
Yeah.
I don't want to go after the corner case that you ran into 3 years ago in your data center and it was really hard, right? Those are good to solve too, but it's just man, where can we make it easier for users? To kind of troubleshoot these things. And so that's the approach that we've taken.
Yeah, aim for 80% and you'll get most of your absolute use cases.
Yeah, that's been that's definitely been the goal. So it makes a ton of sense. We've done other things if people are familiar with the Marvis chatbot, right? I think everybody now, chatbots are going to become table stakes, right? Let's just be real. They're going to become table stakes. I mean, This kind of goes back to the other thing, though, right? I was the first thing we should do with our chatbot is make sure that people don't have to go and docs again, right? If I can go ask a chatbot a question and get an answer back with a high degree of confidence in that answer that it's accurate, and then also give me some proof behind that, right? So we've taken the Marvis chatbot that people are used to with Wi-Fi, and we've kind of expanded that everywhere. So I'm here talking to you about data center. We've added in all of the documentation, to it. So now you can just go query the chatbot and ask it questions and get information back. But we've added other Juniper products in there as well, as far as documentation goes. And so the next step on that, where we're going next, is actually using the chatbot as a conversational interface to pull state data out of the network, right? So if you think about that graph database that I talked about, we have this really powerful single source of truth. What if now I just wrap this conversational interface in front of it that allows you to just ask normal questions in normal human language and get back, meaningful information about the live state of your network. And again, not on a switch by switch level. I think that's the other part of this that is really nice, right? There's there's, you could take a chatbot and say, okay, let me go ask on a switch by switch level what's happening. That doesn't help, right? Especially like in modern data centers, the scale out's pretty big.
Yeah, absolutely. So we've kind of talked about the physical interface, the cabling and stuff like that, but now let's go up a layer, right? Like, can it help us troubleshoot routing protocol issues?
Yeah, it can. Like, we'll call out things like BGP mismatch. So for example, like if the peer ASN is different than what you have configured, right? Like we'll call that out, but we won't just call that out like again in a message that you have to go dig through. We actually use like the virtual network assistant to kind of show you what that looks like.
AI apps is great if but if you don't know what to chat for or what to look for, like it's almost like it doesn't help you that much. So how does Apstra surface these problems to you as the operator? I was going to ask. So
yeah, so again, great question. We're using essentially, it's called the Marvis Virtual Network Assistant, and we have the Marvis Virtual Network Assistant for data center. So again, for the Wi-Fi folks, they're going to be pretty familiar with it. It kind of gives a little bit of like this octopus layout view, and tells you like, here's the Marvis actions to go take. And what it does is it kind of summarizes different information under categories, right? And what we've done on the data center side is we've said, okay, the different categories like layer 1 and 2, we kind of bundle things underneath that, connectivity, device stuff, things that's going on around like traffic capacities. So we might be looking at like hot and cold interfaces. We'll surface this in kind of like this easy to consume. Some folks call it a coffee cup view, and I kind of like that because it's like, I'm abstracting away a lot of like the low level detail and just providing it to you really like high level for you to, you come in the morning, you're a knock or something, right? Maybe you turn around and you just take a look at this, right? While you're sipping your coffee, you kind of take a look at it and you say, hey, is there something here that like I need to pay attention to? Maybe you go look at it and you say, all right, man, this device has an issue and it's triggering an environmental alarm with a power supply. So we're gonna call that to the forefront, right? And you might look at it and you go, oh man, that's no big deal. Like that's a new rack getting installed. We put that switch in last night. All right, I'll get somebody to look at that, but not really impacting. Now we then take that like a step further. So the other thing that we've done, and to me this one's like pretty important. If you we've taken a step further with what we call service awareness. And what service awareness does is it's actually like mapping the services and applications running in your data center to the infrastructure and the resources that it is dependent upon. So what do I mean by that? I kind of think back like to my days as a network engineer and doing net ops, and it'd be like some application issue, right? You're running a big enough company, there's always something going on. Some application issue going on in an enterprise, and like the application is doing a database query and it's slow. Database team's like, database looks fine. Everybody's like, must be a network issue, right? Like it said slow, so it's got to be a network problem. So it's like, there's a P1 going on because I don't know, like maybe it's a booking engine for a hotel, right? Like that's a pretty big impact, so you're like, all right, like we got to get this fixed. And so, you're the network guy, you get called, you jump on the P1, you're like, oh, what application is it? Oh, it's okay. Well, it's, it's the lodging booking app. Oh, okay. What's the IP address of the SQL server that's used? Well, there's this load balancer VIP, and it's actually, okay, well, which server is it actually using right now though for that one query? And, you kind of spend all this time like back and forth, right? And then you're like, all right, let me go look at an ARP table and go figure out where that server's connected to. And then, I see it's, on leaf 6 port 14, right? And so you're looking at that, and then you realize like, oh, actually port 14 is part of a lag. I'm kind of going on and on about this, but, I think anybody in like a NetOps hat, right? You're familiar with this, right? You've kind of gone down this track, and then, you go look at everything and you're like, well, I looked at both like, I looked at the BGP table, I looked at the VPN table, I'm seeing the type 2s, like I'm good, everything looks fine there. And so, they're like, hey, you've been quiet on this P1, hey, network engineer, how are things looking? And you're like, well, I checked the VPN table and I see the type 2 routes, right? Like everybody else on the call is like, I don't know what this guy's talking about, right? Like it's utterly meaningless to the rest of your organization. And what you really need to be able to do is like, how do we get to like mean time to resolution? I actually think like mean time to innocence is such in the networking world. Nobody, like, what do? You hang up the phone and you're like, good luck troubleshooting this. The network's fine, right? Like you're not helping your employer, right?
Yeah,
like you're not.
Yeah.
So to me, this is all about like, how do I make the network person, give them, you're still the network engineer. You're not the application guy. You're not the database, you're not the DBA, right? Like, no, but how do we empower you to be able to talk back to your organization in ways that are meaningful? And so with service awareness, what we've done is we're actually turning around and taking like flow data plus the topology, and we map out. So we'll show you like, hey, I have this server's connected to this leaf. And out of that server, we have like these services that are running out of it. So what do I mean by that? Like SQL service is turning around and running out of server 1, but it's also running out of like server 4 and server 7 and server 8, out of these different ESXi cluster. Because again, data center, everything's distributed, right? And so, you say like, well, these services are running out of here, and so I see where this is going. So you don't have to ask those questions, right? You automatically know already. And even if that's in a particular VRF or a routing zone, again, like with Apstra and Apstra Cloud Services is an extension. It's just another way that we're delivering, services around this. It tells you all of that. It does all the discovery for you. All of that is essentially built in, right? You're not having to go do this. So now you can map those services that make up your critical application or any application, quite frankly, to it. And the other thing that we've done to kind of like bring to surface, what we think is important back to the user in a way that we can build that into a product, right? That we think. So we do things like we bundle traffic together. So when you first go look at this, right, we're going to show you like within a given time frame, and it could be like a 15-minute increment, it could be an hour, it could be a day. We're going to go show you like, hey, here's some chunks of data, right? So like these 14 services make up, 700 gigabytes of data that was transferred in the last hour, for example. And then there's like 27 other services, but they made up like, I don't know, 2 gigabytes of data, right? So we kind of show that to you like in these kind of different blocks, but the idea is like, draw your attention to the 700 gigabytes of data, because more than likely, either A, one, that's the one that you could be of interest in, or B, the inverse could be true. It could be that there's no data because there's a network issue and nobody can access the application. But either way, right, like you can start to kind of like divide these things and start. Everything that we've done is kind of like, and I think this is an important approach, right? You got to kind of like abstract things out a little bit to figure out like, how do I give a high level view first before people dive deep, right? Because if you dive deep too quick, you kind of put yourself down a rabbit hole, and you might be in the complete wrong direction than where you need to be.
Well, I think this is great because when I think back to when I owned a network, I had all of these tools that checked a box, right? Like it was a requirement to have a log collector, and a requirement to have this, and a requirement to have that. I didn't use it, and even when it came to troubleshooting, I forgot that I had it at my disposal. And even if I did use it, it was just so full of information, I couldn't make anything of it. It just caused more confusion and heartache than actually helped me. So to have something that can look at and examine this data and make it useful and provide me some, decisions or some really useful information rather than cloudiness, this is great.
Man, I know that pain all too well, AJ. I'm right there with you. Like, I remember, working in a fairly large enterprise. I mean, we had 9,000 switches and routers in our environment, right? Like, it was pretty decent size, 4 data centers, 58 different campuses. And the security team brought in like a new SIEM solution, and it was like, hey, we need you to send syslog messages from all your devices to this thing, right? And it was like, okay, what do you want me to send there? Like any, and I'm like, I'm not sending you any, like, so we kind of had this. Well, why not, right? Like, why are you trying to keep stuff from us? Like, no, I'm not. My network is not going to be the top talker, right? Like my switches are not going to be the number one thing using bandwidth on this network. And anyway, we long story short, like we had this negotiated. We were sending all this stuff in the SIEM along with, everybody, all the servers, everybody. And it was like, they wouldn't let me get access to it.
Yeah.
Well, our team can't troubleshoot. Like, I just want read access to be able to and they're like, no. Like, that's a security risk. Okay. So yeah, I feel the pain.
Yeah, I think the number one thing that AI ops at any level can do for network teams is that correlation piece, to be able to draw insights and surface them in a meaningful way, because we all have access to thousands and thousands of data sources. We have all got SolarWinds or some version of NetFlow that's running, and we've all got the SIM, maybe not the SIM, but like syslog, and all the box checked, like AJ said. But when it comes down to it and there's a P1 and everybody's breathing down your neck, you don't have time to correlate 40 different data streams and try to figure out where they correlate, right?
Yeah, 100%. And the other thing that I think about too, like in that same aspect of it, you're absolutely right. Like, you're getting all this data. The other thing is, you end up with people that like spend a ton of time configuring and setting up the tools, because and don't get me wrong, like the intent is there, and it's like, well, but what if a user wants to do this, and what if a user wants to do that? Well, let's give them every option so they can configure this thing however they like, right? And a lot of times, like, I don't want to configure it however I want. I don't want to become an expert in this one tool, right? Like, I just want it to set up and work and give me value. and that's the other thing that I really like about the kind of like the idea behind AI ops as well, right? Is it's like, if I have a whole set of data, and I could just kind of like point something at it and give me meaning back, right? And I mean, this is a gross oversimplification of what's happening, but if I can go point something at it and give me meaning back, right? Like, if I can go leverage a RAG and, understand like how to go do that, and now like I just turn around and use the RAG to go do that, right? It's to me, like, that's the part that gets me excited, is like, oh wait, I don't have to, here's a tool that we have for you, but here's a 1,400 page book on all the different configuration options. It'll take you a month to go figure out what it's capable of, and another 3 months to set it up, right? Like that.
Or you gotta
painful.
Get a vendor to set it up for you, whose the whole sole business is going to set up this this application.
Absolutely. Yeah, no, absolutely. And I think like that's the part that kind of gets me excited. And then even better, right? Like the technology, as we've been working on this in Juniper, we've watched like the paradigm shift in the advancements in technology of AI. It's actually like pretty remarkable. And you got to, again, healthy dose of skepticism. You hear claims, it's like, well, let's go actually, kind of validate that. But, maybe in the networking space, there's all these kind of like tools and interesting things that's been happening everywhere else in the infrastructure stack. There's tools that like the server teams have had for quite some time. Like, let's be honest, right? Like, we've been pretty slow to adopt these things in the network realm. And we're at like the source of all the actual information, right? Like, you can actually see packet level data, right? It's like, what are we doing? So yeah, I'm pretty, healthy skepticism, as I said, but pretty optimistic. I've seen proof in the pudding so far, and I've liked what I've been seeing around AI ops, and I think there's some real value there.
Yeah, Sean, I'm a long time VMware Windows and Windows guy. Like, I did infrastructure for a really long time. So to kind of put an analogy on this, a long time ago on early versions of Windows, you would have to deploy things like Active Directory or any Windows service in a very manual fashion. But as new versions of Windows come out, there's wizards where you click a few boxes and put a little bit of information, and the wizard does it for you. Like in early versions of VMware, if you wanted to deploy VMware vCenter, you had to install Windows Server, install vCenter, set up the database server. And then later versions, you put in some information and it deploys it all for you. And it uses the best practices and security standards and all this other stuff. So why do I want to go hand jam a bunch of that standards and best practices and stuff on a bunch of switches in a data center when I can put in some basic information about what I want my network to look like and have something else go do that for me? It saves me a ton of time. It lets me rise up my skills and focus on other things that AI ops can't handle, that I can handle, that I should be handling. I think this is long overdue, right? Like you were saying.
Yeah, agreed. And it's a great analogy and rings, so true, right? I mean, it's just, agreed. Definitely rings true for sure. And the next kind of phase of this, when we look at it too, right? And I think like Tim, you'd mentioned something a little bit earlier that kind of made me think about it, right? We're also going to get to this point, like, and we're actually fairly close because we can get to it pretty quick, but getting to the point of like, predictive analysis around stuff. So let me bring up kind of an example, one that's there today. If we have this piece that's then called so I talked about service awareness. So if you kind of grab the mental model, and apologies, I can't share my screen, but if you grab the mental model around, okay, so I have a visual topology that maps ports and protocols, and the services in the data center, and oh, by the way, we also show all the clients that are connecting to it as well. Again, we aggregate that, right? Who wants to see, hey, there's 30,000 clients connecting to this service. In the data center, that's not, you don't really need to drill down into one. We give you the option to do that, but you're more interested, in kind of hey, there's 30,000 clients connected to the service. That's a great thing, right? That's good. Hey, there should be 30,000 and there's only one. That's a problem, right? And so, one, we surface that right away in service awareness, but then you get to impact analysis, and what we've done there is we're actually turning around and we're taking those anomalies that occur that I talked about, from Apstra, right? Where the cabling mismatch, we call that an anomaly, and we have a bunch of others. BGP mismatch. There's a bunch of predefined probes in Apstra itself that we turn around and highlight these anomalies on, and with impact analysis, we send these anomalies basically from your Apstra cluster. They're able to get sent into Apstra Cloud Services, which where all this stuff lives. This again is that PaaS layer. And so, now we're able to say okay, you have this service and these applications running, and then you have this event or this anomaly that happened on your network. And then we turn around and we say, all right, because of these events, one, we're going to group them together where there's already correlation, we're doing that correlation for you, right? So we're going to group those together. And then two, we also turn around and we tell you hey, these are the services that could go impact. Case in point, let's just say that you have a fairly large data center and you come in and, one of the power supplies is down on a leaf in a rack. And you're oh, well, if I don't fix, it's got dual power supplies, so I'm okay. Maybe, the other power supply is running a little hot right now, but all right, I'm all right. And you're man, do I need to go get that power supply replaced immediately, right? Or have somebody reseat the power cable, whatever. Do I need to get eyes on that right away? Well, we're able to show you. One is again mapping those services. So power supply has an issue. We'll turn around and tell you these are the services that could be affected, if you don't do something about this, right? We're not saying that they're impacted right now, but we're saying that if something doesn't happen, they could be impacted. So you can easily draw the distinction between a switch or a leaf that there's nothing connected to it and there's no services running on it, or maybe there's servers connected to it, right? There's physical servers connected to it, but there's no active services being ran on that for whatever reason. Who knows, right? Okay, I don't need to prioritize that one, but maybe I have 4 leafs in my data center where this is the case. I'm going to go prioritize the one that I do have active services running on. The other one I bring up, RMAing a switch. It happens, right? We'd love to say that switches never fail. RMAing a switch, or even differently, right? I need to swap some switches. Maybe you're doing a generation update of your fabric, inside the data center, and you have to go to a change board and you have to go coordinate with another team to go say hey, I need to take this switch offline. Can you vMotion some servers away from the switch, right? We automatically map all that stuff out for you, so right away where all these things are connected, what services are going to be impacted. You'll know oh, okay, again, hey, it's the SQL service that's running, and it's running in VRF, for this VRF for this point of sale system. I have its own virtual network and its own VRF. And so you'll know okay, it's the SQL service that's running in that VRF. Let me go and talk to that team, because I need to go kind of map that out. So it helps with capacity planning, maintenance actions, all those types of things. Again, they're not always the sexiest thing to go and talk about, and make a big marketing splash about, but these are impactful for everyday type of stuff, right? To people that are doing the job.
Yeah, I mean, how many times have I had to temporarily move a service or whatever, and forgot it was there and did something to the switch, and oh yeah, that, yeah, ooh.
Yeah, and other things just in Apstra too, right? Because it's just an extension of it. We have things like drain mode, so you can go put the switch in drain mode, and it'll when you do that, right, it's going to basically drain all the traffic off that switch. You don't have to go in there and figure out how to manually configure it and change BGP values and all those types of things and manipulate the NLRI. It'll turn around and do that for you to drain all the traffic off of it. And then we'll actually alert you if there's traffic over like a certain threshold. It's configurable, but there's like a default threshold. So it'll be like, hey, if there's over like, a megabit per second of traffic on the switch as a whole, right? Like it'll generate an anomaly and tell you like, hey man, and it only does it when it's in drain mode, by the way. So it's like that switch is in drain mode and you're getting more than 1 megabit per second of traffic on there. Like there's something going on.
Yeah.
Right.
Yeah.
That makes sense.
Yeah. So there's some cool stuff like that. And then where this is going too, right? You can think about like, now you start applying some machine learning and you can start doing like behavioral analysis and trending and, predictable type of analysis that's very specific to your environment, right? So, these are the things to me that's always important as well, right? Like we might try and say like, hey, these interfaces on this switch is cold, right? But if you go back and you think about like whatever your type of business is, maybe you're a type of, operation that like Monday through Friday is when all the traffic is, and on the weekends, nobody's using your data center that much, right? And so, rather than getting alerts that the interfaces are cold on a Saturday, right? Now it could be like, all right, well, look, like we know for your environment because we've turned around and essentially, I remember like trending analysis isn't new, right? Like that's not a new thing. There's all sorts of tools that go do that. I remember having to do that and like you had to baseline it for at least 30 days and usually 60 because I had to get like the full cycle of whatever your normal business operation was in to do even a minor trend, right?
Yeah. Mm-hmm.
Now, like with ML, right, you can go run that calculation that was being ran before much faster, right? And that's the cool part about it. Like you can do this much faster and get value out of it a lot quicker. You don't have to be like, well, buy this tool and in 6 months we'll know what your baseline looks like in your environment. Like, no, you can do this a lot faster.
Awesome. This is I'm surprised that I'm glad I brought a healthy dose of skepticism, but you're winning me over and
well, that's good. And like I said, look, the skepticism is good. We have different things to people can go take a look at this. For Apstra customers, it's really easy to use. For Marvis customers, there's also integration between Marvis and what we're doing on the data center too. It has the same look and feel, so that part is really nice. And then, for folks that aren't a Marvis customer, not an Apstra customer, look, there's marketing videos and demo videos out there, but of course, anybody at Juniper will be happy to walk you through it. You can always reach out to me as well. So yeah, the skepticism again is, like I said, I think healthy and people should approach it and ask questions and be inquisitive and ask to see it, right? Like don't, from any vendor, like from anybody, us included, right?
Agreed.
Like, vendors should be earning your business every day.
Yeah.
I'm a big believer in that.
And two important points here. So one is we're talking about Apstra, and that's not just Juniper, that's vendor agnostic. That works with, so everything that you've talked about here tonight works. That's a good point. Works with any switch, right?
Cisco. Yeah. Well. Anything. To be fair, there's switches that we qualify.
Yeah,
so any switch qualified by Apstra. So yes, obviously we first and foremost qualify all the Juniper QFXs and Juniper devices first, but
of course,
yes, Cisco devices, Arista devices, we support Sonic as well. So yeah.
And then I feel like whenever you start to talk about AI, there's always somebody in the group that rolls their eyes and like AI is going to take our jobs, and I don't hear that in this conversation. This sounds like the coworker I wish I had, not somebody that's going to replace me.
Well, the way I look at it, and I can't remember, I wish I remembered exactly who said it because I'd want to give them appropriate credit, but it was like AI is not going to take our job. Somebody that uses AI is going to take your job.
Yeah.
And the difference is, right? Like, I mean, I use different AI tools all the time in my day to day. And it took me, like, I was slow to do it, to be honest with you. It took me a little while to be like, okay, I need to change my way of thinking around this, right? But it's like, it just allows you to be more efficient, And so really it's like, that same approach here, right? Like it allows you, to be more efficient. Like that's the goal. So again, it's not, like you're not going to be able to, like, AI is not, again, like the magical wave of wand. Let me just throw AI at something and we'll make it all, make it all better. You need good data, right? The data, like data in, data out, still applies.
Very, very
like, you can't get rid of that. You can't. I mean, if you think about it, like, and I'm going to oversimplify it quite a bit, but it's like, it's a lot of math, right? Like
it is.
It's a ton of math and math transactions, right? Like, it still needs good data to run that math against, right? You can't, and this is why, again, like, kind of tooting the Juniper horn a little bit, but this is why, like, in the Apstra framework, because we have that graph database, this is why we went that route in the data center, right? Was like, we have the data that we're collecting, and we also collect all this telemetry data, right? Like, already. So now it's like, well, I'm going to throw AI at that. Like, I don't need to, since I know the state, I already know all these things. I know what it should look like, like, now, like, let me go help, solve some kind of operational challenges here. So yeah, it's a much different kind of approach, I would say, than people are probably used to.
Well, I mean, 100%. Like, if you're responsible for updating documentation and you have to run into a problem and you pull out your network drawings and you go, God, these network drawings suck. They're not up to date. Well, like you said, good data in, good data out. If you don't update your network drawings, you can't use them to troubleshoot. Now, with this,
same concept.
Yeah, same. It's a live network map that just updates itself as changes are made, and when problems happen, it's correct data right there.
100%. I've been sipping on my water cup, but I have my other network engineering sticker.
Awesome.
On there, so.
Well, we appreciate that. Sean, this has been a fun conversation. Is there anything else you want to add before we put a bow on it?
No, I don't think so. Yeah, not sure if any like questions or anything came in. I wasn't looking, to be honest with you. But yeah, hopefully it's been helpful for folks, and just a little bit of what we're up to in the Juniper space. If you have further questions, reach out. And if you also just have questions, if you're just interested, I mean, at the end of the day, like, I'm a network nerd at heart, so I don't need to come around and give everyone a product pitch around stuff. People are just interested in kind of like what we're, like, just our experience and kind of what we've done, around this. Feel free to reach out as well. So happy to share.
Awesome. Well, if you want to learn more, you can go to juniper.net/A1, and he is at Sean LV on X/Twitter, whatever we're calling it these days. So if you have any follow-up questions, you can certainly reach out to him there, or leave a comment wherever you found the show. Sean, thank you so much for joining us. I really appreciate it. And Tim, thanks for co-hosting tonight.
Yeah, that's been great, man. Thanks for dropping by.
Awesome.
Yeah, thank you, gentlemen. Appreciate it. Great conversation.
Absolutely. And we'll see you next time on another episode of the Art of Network Engineering podcast. Hey everyone, this is AJ. If you like what you heard today, then make sure you subscribe to our podcast on your favorite podcatcher. Smash that bell icon to get notified of all of our future episodes. Also, follow us on Twitter and Instagram. We are at Art of NetEng. That's Art of NETENG. You can also find us on the web at artofnetworkengineering.com, where we post all of our show notes. You can read blog articles from the co-hosts and guests, and also a lot more news and info from the networking world. Thanks for listening.